All right, this is Wednesday's lesson. You got to tell me, you have to determine if a relation is a function. Relation is a fancy word for something in math, like a graph, an equation, a table, something like that. So everything in math is either a function or it's not a function. There's a lot of fancy words for this. It tells you that it's the each element of the domain is exactly paired with one element of the range. What that means in regular English is that all the x's are different. That's the important part. We don't really worry about the range. We just care that all the x's are different. All right, that's the key to a function. And you can tell if something is a function with a set of ordered pairs, with a table, mapping, and a graph. So let's go through each one real quickly. And this one is telling you it's the function because the numbers 2, 4, 3, 5, and 0 are all different. None of them repeat. But if you look at the one that's not a function, you have 2, so that's 1. You have 4, you have 3, and the 2. Those 2's repeat, so that means it's not a function. That one's not a function. All right, with the table, this is even easier. Look at your x's. You have 2, 4, 3, 5, and 0. Those are all different, so that make it a function. With the other table, the x's of the domain is 2, 4, 3, 2. So these 2 repeat. That means it's not a function. The third example is a mapping, which is a different way to put all your ordered pairs. And this ordered pair right here, the first one, the 0 goes to the 1. You'd write this ordered pair as 0 and 1. That's the ordered pair. The second one, 2 goes to 3. This will be written as 2 and 3. I'm just going to go ahead and make a table of that if I'm unsure of how to read it. 3 goes with 6. If the domain is 4, the range is -1 in this one. And if the domain is 5, the range is +1. Looking at our definition before, are all the x's different? 0, 2, 3, 4, 5. Yes. That makes this a function. The other table, it's really easy to tell if you write the ordered pairs. 0 goes with 1. Then it says 2 goes with 1. Well, then 2 goes with 3. Because 2 goes with 3, these x's repeat and it's not a function. Lastly, with our table, the graph. If you write down the ordered pairs, there's a couple ways to do this one. Look at the ordered pairs. This one is 0 and 1. That's that ordered pair. This ordered pair is 2 and 3. This ordered pair is 3 and 6. This ordered pair is 4 and -1. And this ordered pair is 5 and 1. If you look at all the x's, highlight each one. 0, 2, 3, 5, and 4. They're all different or they're all unique. So that makes it a function. With the one on the right hand side, this is 0 and 1. This point is 2 and 1. This point, I guess you can't see with my hand. This point is 2 and 1. This point is 2 and 3. Because these two repeats, these 2's repeat, it's not a function. Another way you can tell is by drawing vertical lines. If you draw vertical lines through it, vertical lines go up and down. It only goes through one of the x's. If you go here, it goes through one of the x's. And if you go to this one, it goes through 2 of the x's. It goes through more than 1. That means it's not a function.